Example 3. So we have a truss here. And there's a load of 90 kilonewtons there, and there's also a load of 90 kilonewtons there. So let's consider moment equilibrium. So let's say that we want to take moments around that point there. That distance is 4 meters. That distance is 4 meters. And that distance is 4 meters. And then let's say that distance is 3 meters going up there. So by Pythagoras' theorem, that length is therefore 5 meters. And then let's say that that angle is alpha, and then we can write out sine alpha is equal to 3 over 5, where 5 is the hypotenuse. Cosine alpha is equal to 4 over 5, and then tan alpha is going to be equal to 3 over 4. So that may help us with our calculations later on. Now let's take moments, having sorted out the geometry. In addition, because that is 8 and that's also symmetrical at 5, we could also say that angle is alpha, and then that tells you that angle is also alpha. So we can make use of some of these in the future. We might want to assume that every single member is in tension, so call tension positive. So let's put some arrows on the members. So all of these arrows are in tension, and then let's put the final one there. And then we sort of have a numbering system where this member is 1, this member is 2, this member is 3, this member is 4, this member is 5, and just this member is 6. Now, if we take moments about the bottom reaction, we've got 90 kilonewtons multiplied by 4 meters plus 90 kilonewtons multiplied by 12 meters and that must be equal to that reaction up there, which I'll just call RB, and that needs to be multiplied by 3 meters. So then from there we get RB is equal to 480 kilonewtons. So let's write 480 kilonewtons there. So obviously this one here are all clockwise moments, and obviously RB is an anti-clockwise moment. RB times 3 meters is an anti-clockwise moment, so we've got clockwise equals anti-clockwise, and then from there we've got RB is equal to 480 kilonewtons. So by virtue of horizontal equilibrium, that is 480 kilonewtons. Now if we look at member 5, we can see that we've got a force going from left to right of 480 kilonewtons, so that must be balanced by a force going from right to left of 480 kilonewtons. But we want to adopt our sign convention of tension is positive, because that's going to help us later when we tabulate the values. So we might as well write negative 480 kilonewtons there, bearing in mind of course that we're showing tension as being positive, so a negative 480 effectively means compression. So in terms of the vertical equilibrium now, we've got 180 kilonewtons acting downwards, and therefore since that member there can't take any vertical reaction, or the vertical reaction goes up here. So we could say that value is going to be 180 kilonewtons. Okay, so now let's look at member 2, and let's do method of joints. So we've got 90 kilonewtons downwards, we've got a force which I'm going to call F6, and then we've got force going upwards which I'm going to call F2. So obviously that angle there is alpha. So on one side we could write F2 sine alpha, which will get you the vertical force. That must be equal to, since that force is acting upwards, that must be equal to a downward force of 90 kilonewtons acting downwards. And so we get F2 is equal to 90 kilonewtons divided by sine alpha, and remember that sine alpha is equal to 3/5, so we get 90 kilonewtons divided by 3/5 going to be equal to 150 kilonewtons. So this force here is going to be in tension, and I might write 150 kilonewtons to show the value of the force. Now let's have a look at the horizontal equilibrium. So we've got F6, which is acting from left to right, so that must be equal to the negative of F2 cosine alpha, and that's going to be equal to minus F2 times 4 over 5, and from there we get minus 120 kilonewton. So this member 6, is going to be in compression, and I'm going to write minus 120 kilonewtons there. So let's have a look at the intersection of members 1, 2 and 4. So of course there are faster ways of doing this, but we know that that value there is going to be 150 kilonewton. We also know that that value there is going to be F4, and that value there is going to be F1. Drawing them all in the direction of tension is positive for the members, i.e. make sure the arrows is consistent with the arrows we can see on the truss. So from there we get F4 sine alpha. So remembering that value there is, that angle there is alpha. If you add that onto 150 kilonewtons, also times sine alpha, bearing in mind that that angle there is also alpha. Equilibrium tells you that needs to be equal to 0, and therefore F4 is equal to negative 150 kilonewtons. So you could see that you could actually have written that directly if you wanted to. F4 is equal to minus 150 kilonewtons. So let's put that onto the drawing down here, and we put minus 150 kilonewtons. Now the last place that we can interrogate is the joint up here. Actually, to get F1, let's forget about that. Let's do F1 plus F4 cosine alpha minus F2 cosine alpha, and that's going to be equal to 0. So we're just obeying the convention of tension is positive, so all our arrows have been drawn in the tension direction, so the negative signs of compression and tension will come out in the wash. So from there we get F1 is equal to negative F4 cosine alpha minus F2 cosine alpha So I think that should be a plus. No, sorry, that should be a minus. So that one should be a plus. So F1 is equal to F4 is negative. So negative times negative is 150 times cosine alpha, which is 4 over 5, and that needs to be added to F2, where we know that F2 is 150 times 4 over 5, So of course, since F4 is negative, the two negatives cancel each other out, so you get 150 times 4 over 5 plus 150 times 4 over 5, and that's going to be equal to 240 kilonewtons. So let's write 240 kilonewtons for F1. And then the last one that we need to worry about is this F3. So let's take equilibrium. We've got 180 going upwards. We've got 480 going in that direction there. We've got 240 going from left to right in tension, and then we've got our F3, which is that force down there. So of course that angle is alpha, and that angle is also alpha. So let's take equilibrium, call that F3. So we have F3 cosine alpha, which is in the direction left to right, plus 240 kilonewtons minus the 240 kilonewtons, and that's going to be equal to 0. And then from there you get F3 is equal to negative 240 plus 480 divided by cosine alpha, and that value, when you calculate it, comes out to be positive 300 kilonewtons, which obviously means tension, and so we'll write 300 kilonewtons there. So for example 3, so far we've been able to calculate every single force in every single member, and we've assumed that the direction of the force is always in tension, and the negative sign, which has turned out for 3 of the members, means that that member is actually in compression.